everyone, today we're going to be talking about how to solve systems of equations with substitution. So as we've talked about before, there are three different methods of solving systems of, or I guess 4 different methods of solving systems of equations. One is using tables like we've talked about in a previous video. The second is with graphing. The third is with the substitution, which we're going to talk about, and then the last one will be elimination. We'll talk about that in a little bit. So with substitution, we're going to substitute one variable into another equation and then solve for one variable, then solve for another. Seems really confusing, but it is actually pretty easy. So let's just start with the examples. The first example says y is equal to -8 and y is equal to x minus 12. So obviously they already gave us one of the answers. They told us that y is equal to -8. Because we already know that y is equal to -8, the only thing that we really have to solve for is our x. We have to figure out what x is. Now, the way that we're going to do this is with substitution. And so what I'm going to do is I'm going to say, if I know that y is equal to -8, then this y down here also must be equal to -8. And so what I can do is replace the y on the bottom with a -8 and just rewrite the equation as -8 equals x minus 12. And now I have one equation with one variable, which makes it really easy to solve. So to solve this, I'm going to add 12 to each side. And the 12s cancel out on the right side. I'm just left with x. And then -8 plus 12 on the left side would give me 4. And so that tells me that x is equal to 4. That's actually, I'm done, because now I know that x has to be equal to 4. And y is equal to -8 because the question actually already told me that. Those are my 2 solutions. All right, so what if it's not that easy? What if they don't actually give you one of the solutions? It's still pretty easy. What we're going to do for the second example, we have y is equal to 3x plus 2 and y is equal to x minus 2. So unfortunately, we can't just plug something in, but these 2 y's are the same y. And so what we can do, if they're the same y, we can actually replace one of the y's with one of the other equations. So what I'm going to do is I'm going to say, well, if this y is equal to 3x minus 2, then this y must also be equal to 3x minus 2. So what I'm going to do is replace this y with 3x minus 2. So I'll say 3x plus 2 equals x minus 2. So I just replaced the y with 3x minus 2. Okay? Now what we're going to do is take this equation and solve it for x. And so to solve it for x, I want to get the x's on the same side. I'm going to subtract x from both sides. Just to get the x's on the same side, I've got 3x minus x on the left side, which would give me 2x plus 2 equals the x's on the right side cancel out, and I'm left with -2 right here. Then I'm going to take the plus 2 and subtract 2 from each side. The 2's on the left cancel out. I'm just left with 2x. -2 and -2 on the right side give me -4. Then to get rid of the 2 on the left side, I'm going to divide both sides by 2, which would give me x is equal to -2. Okay, great. We know one of our answers. This is only half of our answer, though, because we don't know what y is yet. But once we get one answer like this, we're going to actually, it's really easy. What we'll do is plug it into one of the original equations, and it doesn't matter which one, whatever one looks easiest, to figure out what y is. So in my opinion, the bottom one looks a little bit easier. So what I'm going to do is I'm going to take it y equals x minus 2. But I know now that x is equal to -2, so I'm going to replace the x with -2, which gives me y is equal to -2 minus 2. And then I can plug that into a calculator, which would give me y is equal to -4. And now I have both my answers. I know that x has to be equal to -2 and y has to be equal to -4. All right, so let's backtrack and just say this. If you have 2 equations that are set equal to y, you just set them equal to each other and solve for the x first. let's go through a slightly different one. So on example number 3, you have one equation that's set equal to y, and then another equation you don't have y for. So what you're going to do here is similar to what we did last time, but because I know this y is equal to negative 6x minus 6, I know that this y is also equal to negative 6x minus x. Then what I can do is rewrite that bottom equation so it's 3x, but instead of saying minus y, I'm going to say minus negative 6x minus 6, because that's what y is equal to. Then, and then equals negative 3. So I just rewrote the bottom equation, replacing the y with what I know y is equal to. Now I'm going to simplify and solve that for x. This negative would distribute into the parentheses, so now I get 3x plus 6x, because the negatives cancel out, and then plus 6 is equal to negative 3. Then I can combine like terms. The 3x and the 6x would make 9x plus 6 is equal to negative 3. I'm going to solve that for x by subtracting 6 from each side. I'd get 9x is equal to negative 9. Divide each side by 9, and you'd end up with x is equal to negative 1. Now that we know that x is equal to negative 1, what we can do is take one of the equations, whatever one looks easiest, and in this case, I think that first one looks easiest, and then plug the negative 1 in for our x and solve for y. So to do that, let's just rewrite that top equation. Y is equal to negative 6x minus 6. And I'm going to replace the x with what I know it equals, which is negative 1. So I'm going to say y is equal to negative 6, but instead of saying x, negative 1 minus 6, I would get negative 6 times negative 1 is a positive 6 minus 6. Well, 6 minus 6 is 0, which means that y is equal to 0. So my final answer right here is x is equal to negative 1 and y is equal to 0. All right, last one, and this one's super similar to the third example. So we know on this top equation that y has to be equal to 3x minus 17, which means that this y also has to be equal to 3x minus 17. So I'm going to just rewrite the bottom equation, but replace the y with 3x minus 17, because I know that's what y is equal to. Now we're going to solve this for x. To solve it for x, we're going to distribute this negative 7. So I'd get negative 2x minus 21x plus, because the negatives distribute, and then 7 times 17 is equal to 119 equals 4. Now we're going to combine like terms, which are the two x's. So I'd get negative 23x plus 119 is equal to 4. Now I'm going to solve that for x by subtracting 119 from each side. You'd get negative 23x is equal to negative 115. And then we're going to divide both sides by negative 23 to get rid of that. You'd end up with x is equal to 5. All right, now I know x is equal to 5. That's great, but that's only halfway done because we also need to figure out what y is equal to. We're going to pick the easiest one again. I'm going to say it's the top one again. So y is equal to 3x minus 17, but I'm going to replace the x with what I know it is. I know x is 5, so I'm going to say y is equal to 3, but instead of x, say 5 minus 17, which would give me 15, because 3 times 5 is 15, minus 17, and then 15 minus 17 is equal to negative 2, so y is equal to negative 2. So my final answer in here is x is equal to 5, y is equal to negative 2, and there we have it, how to solve systems of equations with substitution.